This is a tutorial on how to use a calculator to make regression lines to model data. Now let's start off with our first example. So here we have a table relating the temperature in degrees Celsius to its corresponding temperature in degrees Fahrenheit. Now if we want to make a regression line to model the relationship between these values, we must first figure out what type of function would best represent that data, or best model that data. So to do that, we need to take a look at the graph of each of these points from our table. Now to do that, we need to make sure that our data is in our stat plot, which it is. And then we need to turn our plot on and then graph it. So here, when we're looking at our data from the table, it looks like it's represented pretty well with a linear type function. They pretty much line up to be a straight line. So, when we're making a regression line, we want it to be a linear function. Now let's actually proceed to do that. So in order to make a regression line, we need to go back to Stat, but instead of being under this Edit tab, we need to go over to Calc. So we'll scroll to the right, and now we see this list of various options. Now where you see these regs, or REGs, those are all different kinds of regression lines, depending on what type of function the model would be. So for us, we want a linear regression. So we would choose option number 4, and then hit enter. Now at this point, we would specify which lists our data is in. So first we would start with the input list, which is L1, and then comma, put in the list for our output, which would be L2. But for the calculator, we actually don't need to do that. If we leave this blank, it automatically does L1 as our input and L2 as the output. So we could just hit enter. Now at this point, you could see up at the top that the calculator gives us a general function, y equals ax plus b. But for our particular data, the constant a is going to equal 1.8, and the constant b is going to equal 32. So when we write out that function, it would be y equals 1.8x plus 32. Now when you're creating these regression lines, you don't necessarily have to use y and x. That's just what the calculator uses as a general standard. So you could change these variables to fit your particular needs. So for example, with the data we have now, we could change our output to be F, representing the temperature in degrees Fahrenheit, and our input variable to be C, to represent the temperature in degrees Celsius. So our function, or regression line, to represent this data would be F equals 1.8C plus 32. Now there's a way we could check our regression line to see how accurate it is compared to our data. Now the way to do that is to turn Diagnostics on. Now that option you could find under Catalog, which is this blue word above the 0 button. So to get to it, we'll hit second 0. And here you'll see a long list of all the different types of functions and features in the calculator. Now to quickly get to a section, you could just type in a particular letter. So if you notice on the calculator, there's a bunch of green letters above a lot of buttons. Now since we want diagnostic on, that'll be in the D section. So we could hit this button to get to where all the D's are at. So now if we scroll down to diagnostic on and hit enter, and then enter one more time. Now from this point, we can determine how accurate our regression line is. So from this point on, whenever we find a regression line, it will also tell us how accurate it is. So for example, if we go back to linreg to find a linear regression for our data, it gives us some extra information. So it'll still give us our constants with our general solution or general function. Now r squared is called the coefficient of determination. And the value that it gives is a probability representing how accurate it is. So 0 would be completely not accurate, while 1 would be a perfect accuracy. So the closer this value is to 1, the more accurate your regression line is going to be, or the more accurate your regression line is. So in our case, the coefficient of determination is 1, which indicates that our model is 100% accurate. Now let's try another example. So this time we have a table that shows us the height of a ball over time. Now again, like before, we want to see what type of function would best represent this data. So to do that, we'll make sure that our data is inputted into our stat plot, which in this case, we have the input in list 4 and the output in list 5. So when we go to our stat plot, we'll make sure that those ones are selected. So our X list will be L4 and Y list will be L5. And then we'll graph that. So based on this scatter plot, it looks like the data points are exhibiting a parabolic type behavior. So this looks like it would be best represented by a quadratic function. So when we make a regression line for the data, we want it to be quadratic. So let's do that. We'll go to Stat, and then scroll over to Calc. And now the fifth option down, you could see QuadReg. That represents making a quadratic regression line. So we'll hit Enter. Now before we hit Enter again, we need to remember that the lists with our data are not the default L1 and L2. They are instead L4 and L5. So we need to hit L4, comma, L5. Because those are the lists with our input and output for this data. So now that we've done that, we can hit Enter to find the regression line. So this time, since we're doing a quadratic function, the calculator shows us a general formula, or a general function, y equals ax squared plus bx plus c. And then it proceeds to give us those constants, a, b, and c, based on the data in the lists that we indicated. So when we plug these constants into the general function, we get y equals negative 0.13x squared plus 2.04x plus 4.32. Now again, you don't have to use y for your output and x for your input. We could change those to fit our particular situation. So since our input is time and our output is height, we could change our function to be h of t equals negative 0.13t squared plus 2.04t plus 4.32, where t is our time in seconds and h is our height in feet. Now, since our diagnostics are still on, the regression also gave us our coefficient of determination. And in this case, it was 0.974. Now, if we converted that to a percentage, it would tell us that our particular model is 97.4% accurate, which is really good. Now that you've seen a couple examples, you have everything you need to know about making a regression line. But keep in mind that there are plenty of options to choose from. So you want to choose the one that best represents your data